Alright, on lesson 95 we're looking at nonlinear systems, and we have a line and a hyperbola on the first example. And what I'm going to do is use substitution. I'm going to get the y by itself. So I have 6x minus y equals 5. So negative y equals negative 6x plus 5, and then I'll divide everything or multiply by negative 1. So y equals 6x minus 5, and that's what I'm going to fill in for the y here. So I have x times 6x minus 5 equals 4. I'm going to distribute the x, so I'll have 6x squared minus 5x, and then minus 4 equals 0. So I went ahead and also moved that 4 over to the other side because I have a quadratic equation to solve. Now I'm just going to use factoring. So factors of 6, we have 2 and 3, 1 and 6. And then I also need to consider my factors of 4, which are 2 times 2 and 1 times 4. So if I try the 2 and 3, and say I do the 1 and 4, and I have to consider I need a negative 5, so I'm going to try a negative 4 here, and a positive 1. So I'll multiply the middle together, that's 3x, and then I'll multiply the outside together, that's negative 8x. So when I add those together, I'll have negative 5x. So that is the middle number we needed. Then I'll set each of those equal to 0 and solve for x. Now if you're not comfortable with factoring, you could use the quadratic formula and find the x values. So I have 2x plus 1 equals 0, and then 3x minus 4 equals 0. So 2x equals a negative 1, so x equals a negative 1/2. And then 3x equals 4, so x equals 4/3. Okay, now I can put those in for my x here to find out what y is. So I'll put in the negative 1/2. So I have y equals negative 3 minus 5. So y equals a negative 8. So one of my points is negative 1/2, negative 8. And then I'll find my other point by putting the 4/3 in for x. So y equals, I'll go ahead and show this step this time. So here these would cancel and it would just be a 2. So 2 times 4 is 8, minus 5, which is 3. So I'll have 4/3 and 3. So those are my 2 points of intersection. Okay, on the next problem, since we have both x's are squared and both y's are squared, I can go ahead and use elimination on this problem when I couldn't on the other one. So I'm going to add these equations just as they are together, and that'll cancel out my y squareds. So I'll have 3x squared equals 18. Divide both sides by 3. So x squared equals 6, and then take the square root of both sides. So x equals positive or negative square root of 6. Okay, now I can use that to find my y values. So I'll fill that in for the x up here. So I have the square root of 6 squared plus y squared equals 9. And then I'll have 6 plus y squared equals 9. Subtract my 6, so y squared equals 3. And then I'll take the square root of both sides. So my y equals plus or minus 3. Alright, so what we end up actually is with 4 points here. We'll have positive square root of 6 with, oh, that should have a square root with a positive square root of 3. And then I'll have the negative square root of 6 with the negative square root of 3. Then I'll have the positive square root of 6 with the negative square root of 3. And then the negative square root of 6 with the positive square root of 3. And the reason we end up with those 4 is because all of these are squared. So when you put in the negative square root and then you take the square root of your answer, you get plus or minus each time. So that's why we end up with 4 possible answers here. Or 4 points of intersection is what that is. Alright. Now I noticed here that when I typed this up, that the book actually has a -6 here instead of a 9, so I accidentally made a typo there. So mine is a little bit different than the book's, but with the problems I have, this would be your answers. Hopefully this helps in your at least process of solving systems of equations that are not linear.